Variation on the one sample t-test is the matched pairs t-test. The biggest difference between the two tests is that a one sample t, we only have one sample. A matched pairs t-test, we're technically taking two different samples, but these samples are matched up in one shape or form. For example, we could be looking at the before and after of an athlete. We could take their heart rate before they exercise for 30 minutes and then take their heart rate afterwards. So we've matched each athlete up to themselves. Another example would be going to two different grocery stores and taking samples of identical item prices and comparing which grocery store is bigger based on the differences in the price. A matched pairs t-test could actually be conducted by taking the first column, subtracting the second column, and then running a one sample t-test on the difference. That is why they are directly related tests. So let's go ahead and look at the paired t-test that you have in your notes. A researcher measures the cholesterol levels in a group of 10 men and obviously jots those down under the no drug column. Then the men took a cholesterol lowering drug for 90 days and then recorded their cholesterol level after that 90-day period. And the researchers wanted to determine, did the drug actually help reduce the cholesterol levels in these men? So we're going to conduct a 4-step problem. Our state step is that the drug helped reduce the cholesterol level in these men. Our plan step is going to be a little bit different than those that we have done before. A matched pairs t-test is looking at the differences between the two columns. So you want to determine if when you take sample 1 minus sample 2, are you expecting to get a positive or negative response? Our null hypothesis is always going to be equal to 0, meaning that if we take our no drug, subtract our drug, we would get 0, meaning that they are identical numbers, that there is no difference between the two. Our alternative in our situation is going to be greater than 0. The reason being, in our no drug, we expect the men's cholesterol to be higher before they took the drug than after. So if I take their before, subtract their after, I would expect to get a positive number. Therefore, I would expect to get a difference greater than 0. So that would be my plan step. So let's go ahead and go over to StatCrunch and run this test. And I have entered the data here into StatCrunch. If you would like, pause the video and go ahead and enter it into StatCrunch now. Once you have that entered, you're going to go to Stat, T-Statistic, and then we're going to use the paired. We're not dealing with the two separate samples. We're dealing with a paired t-test. Our samples are the exact same size, and they match up 1-to-1. Our sample 1 is going to be our no drug. Our sample 2 will be our drug. And I'm going to save the differences, and I'll show you why. It just kind of gives you a good representation of what the first one minus the second one is going to give you. Click on Next. We're going to run a hypothesis test, and our alternative hypothesis will match our alternative in our plan step, and that was greater than, because we would expect that the no drugs were higher. Click Next. We're just going to leave that blank, and we're going to click Calculate. As you can see, looking at our printout here, our p-value is less than 0.0001, which obviously is quite a bit less than our alpha 0.05. So since we've got a very low p-value, we can reject our null and accept our alternative hypothesis that yes, the men had a higher cholesterol before taking the drug than they did afterwards. And I just want to make you aware of this difference column here in StatCrunch. All StatCrunch did is they took the no drug column and subtracted the drug column and gave you the results. And as you can see, in every single instance in this sample, every one of the men had a higher cholesterol before taking the drug. So that's another good indicator that yes, our results are going to be what we got.